Here we go. Recording. Okay. So here we've got a little cliff and we're dropping something down. Okay. Whatever speed it is, whether you're whipping it down or whether you just drop it, the gravity, the G is 9.8 about. Okay. So in this case, when it's falling down, the gravity gets added to that speed. So that acceleration is going to be added. So in this case, G is going to be positive 9.8 because it's adding to the thing. Okay, the speed of the thing. Now, if you're taking, if you've got a little cannon down here, there's your cannon, and you're going to shoot the ball straight up. Okay, so there's your little vector going straight up with whatever speed it's going at. But this time, now gravity is still the same direction. Gravity is always pointing, well, Earth gravity is always pointing to the center of the Earth. Okay, so this time the G is still going to be 9.8, but relative to this direction going up, it's pulling down. So relative to this, it's going to be negative 9.8. Okay, so all the time when you're doing these things, think about, is gravity making it slower or making it faster? Okay, because this negative is not like an absolute, it's just a direction. Okay, it's a direction relative to the direction of your initial speed. Okay, because we've decided as a group of scientists that we're going to do it that way. We're going to change this to negative because it's negative to the relative to the direction. Okay, so think about, is gravity going against my motion or is it adding to my motion? Okay, that's how you're going to decide whether this 9.8 that you plug in is negative or not. Okay, is everybody cool with this?
Yeah.
Okay, okay, because that's the one thing that I'm seeing most commonly messed up for the acceleration, because in all of these problems about like gravity, the acceleration is always going to be G. It's always going to be G. It's just like, is it adding to my speed or is it taking away from my speed? Okay. That's, in that way, it's easier than some other ones. All right, so then the other thing is the velocity. Which one is V1? Which one is V2? Okay, so V2 is always the later one. Okay, so like if this is dropping right here, it's going to have a V1 equal to 0 because you're just dropping up here. And then this one's V2, it's going to be adding, so it's going to be getting faster, faster. This V2 is going to be bigger, so this V2 is going to be bigger than V1. This V3 down here is going to be bigger than V2 because it's getting faster, 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 faster. The more it falls down. Okay, now on the other side, maybe I should have color coded this. Okay, for the cannonball, I'll do it in green, I guess. There's the cannonball, color in. Okay, so for the cannonball, V1 is going to be whatever speed it got out of the cannon. Say, and the one, it was like 250 meters per second. Okay, this is pretty fast. That's not fast for a modern one, but for an oldie timey cannon, it's about right. Okay, so now this is going to get slower and slower as it moves up because gravity is pulling against it. Okay, which you know, because if you let go of something, you know, here, if you just let it go like this, it's not gonna fly up into the air faster and faster and faster. We would have no universe as we know it if that's how gravity worked. If gravity were a repulsive force instead of a pulling force. everything would be scattered out evenly every place. It would be weird. We would just be like a like a thin soup of matter all over the place. Okay, so then this is going to get faster, faster, faster. V2 is at a different time. V2 is going to be less than V1 if you're going up. Okay, it's going to get slower, 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 slower. Finally, it's going to stop. Okay. Now, mostly, if we shot this so fast that it could escape Earth's gravity, then it's not. Then it's not going to get zero. It's going to get to some. When it escapes the gravity, it's just going to go on and on and on forever. That velocity until it hits something, or gets in the gravity of something else. Okay. So let's do an example. Let's do an example. Let's say, all right, so I have cats, right? I have 4 cats, and they jump up at things. You know, like if you dangle a little feather or something, or if they see a fly, they jump up in the air and try and grab it. Okay, so if here's the let's do a quick drawing of a cat, and it's kind of a squirrel face, but whatever. And it's jumping up. Here's its little paws trying to come up, and then it's jumping, and it's off the ground already. Okay, let's say it's off the ground. This little paws. There's its angry tail, being like, "I will jump and kill you." All right. Okay, so it has some upward velocity. Okay, so we're going to say like it's going up with some velocity. And this velocity, let's say it's, I don't know how fast a cat goes. Let's see, it's 3 meters per second. Okay, and then let's say if it jumps up this far, let's see like how many seconds does it go up in the air before it stops, before it starts falling down again. Okay, let's just say that. So let's say, okay, I'll write it out up here. How long until the cat starts falling? Okay, to figure this out, we need, so here's our equation. Acceleration equals V2 minus V1 over T. Okay, so let's see what are our things. I'll write in a different color over here. So when in doubt, I would say always, and I always do this. I have since I started, and I'm still doing it, and it keeps me from messing up. So write down your variables and what they are. V1 and T. Okay. So what, can you guys see this? Is this okay?
Yeah.
Yes.
Okay, cool. All right, what's the acceleration?
Negative.
Is it, I heard something, but it was a little garbled. Can you say it again?
Negative 9.8.
Negative 9.8. Now it is negative 9.8. How did you know it was negative?
It's going up.
Going up.
It's going up. So what does that mean?
It's slow.
Well, yeah, it's going to get slower. So the velocity, the initial velocity, V1, is in the opposite direction of gravity. So it is fighting gravity. So it's negative from this. Okay, so because this is, gravity is going down like this. So we're going to call that negative 9.8. Okay, so there's that. All right, What's, I don't know why I did V2 first. What's V2?
Zero?
0. V2 is 0 because that's when the cat starts falling. It goes up until it starts coming down. And that point at which it switches from going up to going down is going no place, 0. 0 velocity. Okay, so until that point, what's the V1?
3.
3. 3 meters per second. Okay, what about T? Can we see it from the problem?
Question mark?
Question mark. Yeah, we don't know what it is. That's what we're trying to find. Okay, I'm going to erase this now because I'm not going to erase the cat, but I need some room to calculate. All right. So then, ooh, I got a new. I got a neon. Somebody gave me this. Ow. Dang. I don't want anybody unwrapping this. Ow. There. Okay. All right, so let's calculate. Let's see if this is good for calculating. So I'm just going to plug in stuff and see what I get. Okay, so A is negative 9.8. So I'll put negative 9.8. Oh, that's kind of weird on the white. I'm going to do that in black instead. I don't think that's enough contrast. Yeah, I'll do it in black. Black is easy to see. Okay, so this is negative 9.8 equals V2 is 0 minus V1, which is 3, divided by T, and we don't know what T is. That's what we're looking for. Okay, first thing I do, I got to get rid of that T off the bottom. Oh, what happened to that? Okay, so we're going to multiply both sides by T. Okay, like that. This T crosses out this. So I get negative 9.8 T equals negative 3, right? Okay, then I'm going to divide both sides. No, not by T, that's what I just did. Ridiculous T there. Okay, I'm going to divide both sides by negative 9.8. Okay, so this crosses out, and I get T equals whatever this number is. Let's see what it is. 3 divided by 9.8. I don't have to put the negatives in because they cancel out anyway. And I get 0.306. 0.306 seconds. Okay. All right. Questions about this? Okay. It seems like.
That's a good cat drawing. I just realized how good it is.
Well, I watch cats a lot. Okay, and usually actually is they jump up in the air. They do a weird bending back thing so that they fall flat. I have one goofy cat and sometimes he's clumsy and he'll like fall backwards or something, but he hasn't done that in a while. Okay, let's do another one. Shoot. How we do another one? Okay, so it seems like this is the problem for people. So just make sure that you know, is the acceleration adding to your speed or is it taking away from your speed? And make sure you don't get V2 and V1 mixed up because it seemed like that was everybody's problem. Okay? So try again. I want all those things done by next time. Okay? Bye. Have a good lunch. I'll see you tomorrow.